This video is on exercise 9C, chapter 9 of Pure 2 A-level maths. So this chapter is all about differentiation and some of the most useful techniques of differentiations. And exercise 9C is on chain rule. So let's start by doing question 7. Find the value of dy dx at the point 8, 2 on the curve with equation 3y2 minus 2y is equal to x. Okay. Now we should be careful because we can differentiate this function by using the implicit differentiation because we have y values and x values combined. So we cannot really write y in terms of x. We can write that, but since we have y squared, then we will have plus or minus. So, that's just going to be a big mess. So now we can use the implicit differentiation. So 3y squared differentiates to 6y and dy dx. Minus 2y differentiates to minus 2 dy dx. And x differentiates to 1. Now we need to factorize, so we can write this in terms of, we can write dy dx in terms of y. So dy dx, we take a factor of dy dx out, and we will have 6y minus 2 is equal to 1. Now divide both sides by 6y minus 2, and we will get 1 over 6y minus 2. Right. Now, we haven't done yet because the question says find the value of dy dx at the point 8, 2. So here we should be careful because most of the times when we differentiate something, then we substitute the value of x into that, and that's natural because most of the differentiations that we deal with aren't implicit. However, since here is an implicit differentiation and we only have the y term, so we should substitute the y coordinate into here. And also if we had x here, because sometimes it's possible to get x and y's combined, then if you want to find the dy dx at that point, you need to substitute both x and y coordinates into your derivative at the same time. But here is not the case. We only have the y value. So y coordinate is 2. So here we write 6 times 2 minus 2, which is 1 over 10. And that's the answer. Question 8. Find the value of dy dx at the point 5 over 2, 4 on the curve with equation y to the half plus y to the power of minus a half is equal to x. Okay, this is the same technique, so we can differentiate this implicitly. And y to the power of a half differentiates to half y to the power of minus a half dy dx. So in implicit differentiation, we differentiate the function as usual, but every time we need to write down the dy dx at the end of that. So same thing here, we will have minus a half y to the power of minus 3 over 2 dy dx is equal to x differentiates to 1. Now let's factorize this. Take a factor of dy dx out, and we will get, so I'm going to write these down in a better form at the same time. So here we will have 2 square root y minus 1 over 2 times square root of y cubed is equal to 1. Now let's let's divide both sides by this bracket. So dy dx is equal to 1 over 2 root y minus 1 over 2 root y cubed. Now let's look at the point. So the point is this, and in our derivative we only have the y value. So this is the same as the previous question. So we just need to substitute 4 into this. So we can write down when y is equal to 4, dy dx is equal to, So now substitute that into the derivative. 1 over 2 times root 4 minus 1 over 2 root 4 cubed. Okay. And this is root 4 is 2. 2 times 2 is 4. So here is 64. 4 cubed is 64. And root 64 is 8. 8 times 2 is 16. So minus 16. And, we can write this as usual. 1 over 4 minus... sorry, I should have written this separately. So 1 over 4 minus 1 over 16. So now this is the last step of this question. So it's 4 minus 1, and we get 3 over 16. But be careful. 3 over 16 is the answer of the denominator, but actually the derivative is 1 over the denominator, which means when we get back to here, we will have 1 over 3 over 16, and the final answer is actually 16 over 3, because we are working out the reciprocal of that. So yeah, it's very common to get to this point, especially in the exam, when there is a pressure on you, and you just move on to the next question. Question 9. A. Differentiate e to the power of y is equal to x with respect to y. Very important. So because 90% of times, at least in A-level maths, you differentiate with respect to x, and or you differentiate with respect to your independent variable, if that makes sense. Sometimes it's t, but most of the times it's x. However, here the question is different. So, and it's actually a very interesting question, and it's possible to have questions like this in your exam, which they may have like 2 marks or 3 marks maximum. So before doing this, let me just show you that this is a very important fact that you need to know. So dy dx is equal to 1 over dx dy. So this is very handy, and you're going to use this a lot, especially in the questions that you need to use chain rule. And this comes from here, because it's always good to know the reason. So why? And this is a result from the chain rule, because if you have dy dx times dx dy, then this is not rigorously speaking true, but you can think this as fractions that they cancel each other. But again, this is not 100% true, and you get 1. And if you now, let's say you divide both sides by dx dy, so you will get dy dx is equal to 1 over dx dy. So if you divide both sides by this term, so this term will be gone from here, and you will have dy dx is equal to 1 over this term. And that's exactly the same as this. So this is the reason, and it's very useful to know. This result is very useful. Now let's do this question. So part A is just differentiating this with respect to y. So if we differentiate this with respect to y, we will get e to the y on the left, and because x differentiates to 1, but since this is with respect to y, we will get the x dy on the right hand side. And that's it. So now let's do part B. Part B says, hence prove that if y is equal to the natural log of x, then dy dx is equal to 1 over x. So we already know this is kind of one of the standard results that we had to memorize, and now we need to show that. So you can't just rewrite this again, because we need to show that, we need to prove that. And it's now we are going to use our result from part A. So this is going to be useful, and also this result as well. Now let's see how can we do this question. So we know that y is, because remember that since here it says y is equal to the natural log of x, we can raise both sides to the power of e and see what happens. So we will get e to the y is equal to x, because e to the power of the natural log of x, they cancel each other out, e and the natural log, because the inverse natural log is the inverse of e, so you will get x. And this is very important because this is the same thing as we had in part A, because this will be useful in a bit. Now we can write divide dx, and always remember, when you want to prove something, usually you start from one side and you try to get to the other side. So in this case, we can start from the left hand side, and our objective is to get 1 over x, to just show that that's true. So we need to do some sort of manipulations to get to that point. So divide dx. So now is the time to use this, because we can rewrite divide dx as this form, because they're the same thing but just written differently. So let's just write this as 1 over dx dy. And this is the point where things get interesting, because we've already shown that dx dy is equal to e to the y. So now let's just substitute that into here, 1 over e to the y. And now the last bit is simply using this bit, because we know that e to the y is equal to x from the question, so that we can write 1 over x. And that's exactly what we wanted to show. We wanted to show that divide dx is equal to 1 over x, and that's it. So proved as required. And that's it for this video. Please subscribe for more videos, and good luck.